Hello and welcome to the InfoQ podcast. I'm Daniel Bryant, News Manager here at InfoQ and Product Architect at DataWire. I recently had the pleasure of sitting down with Gareth Rushgrove, Director of Product Management at Snyk. I've been lucky enough to have known Gareth now for several years through the London meetup scene, and he's one of those deep thinkers that often provides different insights into popular ideas and technologies. In this podcast, I was keen to pick his brains around the concept of Kubernetes as a platform and understand what he thought this framework provided and also what it lacked in regards to deploying and operating modern cloud-native applications. I was also keen to explore the current state of Kubernetes tooling with Gareth, with a particular focus on application building, continuous delivery, and security. When Gareth was at Docker, he and his team did a lot of interesting early work on the cloud-native application bundle specification. Now he's working at Snyk, he's doing equally interesting work in the security space. Hello, Gareth, and welcome to the InfoQ podcast.
Hi, Daniel. Good to be here with you.
Could you briefly introduce yourself and your current work, please?
Yeah, certainly. So my name's Gareth Rushgrove. I'm currently Director of Product at a company called Snyk. So we do basically security tooling for developers, covering like open source components, containers, a lot of other things as well.
Good stuff. So I'm keen to start the discussion today around Kubernetes. I know I see you on Twitter a lot, and you and I bumped into each other many times at KubeCon and so forth. Kubernetes is a great piece of foundational technology, but you often have to build a platform on top to get full value of delivering applications on it. Do you think there are core capabilities or core elements of a platform based on Kubernetes?
I might argue a little bit with the premise and then come back to your question, in that I think maybe you said total value. So I think one of the things with Kubernetes that surprises lots of people is both that it's, from a certain point of view, a low-level abstraction. From another point of view, it's a much higher level abstraction than what people were used to before. So I think if you're coming at it from the point of view of, I want my future application platform, it turns out Kubernetes has got low-level building blocks, and you definitely have to build something on top of it. On the other hand, if, like actually the majority of people coming to Kubernetes, you're coming at it from the point of view of, I used to have access to a bunch of VMs, and they could have been on AWS or Azure, they could have been on vSphere, they could have been behind, in lots of cases, a ticketing system. That Kubernetes API is incredibly high level and is basically the API for, broadly speaking, infrastructure you always wanted. So I think it depends a little bit. Like if you do buy into the only route of success is to build your platform on top, which I don't really do. I think what is arguably missing in the Kubernetes API context is the application. You've got services, you've got deployments, which sort of add a layer of abstraction over replica sets and pods. But where's the thing that maps to the sort of, not really the concrete thing, but the thing that I organize my teams around, the things I organize my source code repositories around, the things that I organize my CI system around. And let's, for want of a better word, because naming is hard, call that an application. Kubernetes doesn't have that built in. But there's been a few sort of moves in that direction for a little while.
Very cool. So what do you think your impression is of the current status of Kubernetes tooling? Is it a bit fragmented? Is there opportunity perhaps for defining things like applications and how we bundle our applications together?
Yeah, there's definitely a lot of opportunity. I think that was probably the thing that attracted me to Kubernetes 4 or 5 years ago. I think the first talk I did at the first KubeCon EU was called something like Kubernetes and the Potential for Higher Level Tools. And I still fundamentally believe that. I still find it interesting. I think it's interesting that maybe we haven't moved as quickly as I thought we might. And to a certain degree, I think that's also down to wide-scale adoption. Like, it's not just a bunch of the sort of high-level, high-concept people who were interested in Kubernetes because of that API surface. Actually, loads of people have just been using Kubernetes to get work done. And a lot of practical things come out of that that just don't need these higher-level bits. Because that potential was there, you do see all sorts of tools. And some of them have come and gone, and some of them have potentially been too early. And ultimately getting traction in that space when most people are actually maybe not needing the high-level tools yet has led to a certain degree of fragmentation. I think actually also what's happened was people jumped on Kubernetes very quickly when most of those tools didn't exist and built their own tools. Kubernetes was API first, frankly, and it's relatively straightforward to build tooling on top, so everyone did. I think you start seeing some of that consolidating over time, but it's worth remembering that the project, and especially the majority of users, are still new. KubeCon's a great proxy for that. I think in Barcelona, which was the last EU one, something upwards of 80% of attendees were new to at least the event. And San Diego just gone was 70-some%. Again, like it's easy to forget that most people are new. I think in that context, that's where the problem lies. If they then discover this bewildering set of tools, that can be overwhelming. For my sins, created a spreadsheet a while back that gets other people have added 2 cents and gets circulated around, partly as part of like a narrative of like Kubernetes is too complicated because people have built too many tools on top of it. I disagree with that like view, in that I think it's that we have this new thing, people have been experimenting on top, and ultimately things that see large scale adoption will be the ones that win versus the things that are conceptually most interesting or nice, as with all like developer tooling or sort of operations tooling.
So what's your thoughts on the sort of interplay between, say, pure open source, things like the Cloud Native Computing Foundation, and obviously vendors? I know you can wear many hats because you are an open source person, you are a CNCF contributor, I'm sure, and you are obviously a vendor as well. What do you think the relationships between all those things are?
I think they can be quite individual. Different people are going to come at it from a different point of view. Some of it comes down to what you think about open source and whether you think open source is important, and actually what you think open source is. I was just back from FOSDEM a couple of weeks ago, and lots of conversations there around that. And where I got into open source was about the freedoms. It was about the like you'd have as many conversations about licenses as software, and I'm glad that's not quite there yet. But basically, like at the moment, maybe we've gone through this period where open source simply became synonymous with free. And I think we're coming back to conversations about licenses now a little bit in places, and the sort of the role of things like the OSI. So I think you're going to have loads of different people coming at it from loads of different points of view. For me, open source is something that I sort of believe is important. I think sustaining open source, I don't like the idea of a world where sort of all the free software that becomes popular and sticky is sort of spat out of very large corporate organizations. Not that that doesn't have value to the ecosystem, it absolutely does. I like it where there's a mix. And I think one of the things that I've learned is that big bits of software take a load of people, and gathering that for free takes a long time, is exploitative, is really hard. Doing so commercially is arguably easier. Doesn't mean it's easy. So I like that mix of, yes, you can go out and you can create software on your own or with a small group of people who are interested in a project. You can see open source projects coming from startups, and startups by their nature will succeed or fail. And you see projects coming from end users and large corporate technology companies. And the interplay is interesting. And I think that relationship then is hopefully all about the end user first. And I think sometimes people read too much. Again, like there's always a second. Like if you don't serve the end user first, you're probably not going to succeed in any of those things. You build something for yourself, you're the end user. It's really easy. If you're building something for someone else, whether as a startup or whether a corporate giant, if you're not putting the end user first, over time, it's not going to work out. Maybe I think at the high end, if you have a lot of money and a lot of weight, you can get somewhere quite quickly, and you can certainly squash things. But overall, I think on balance, it'll work out. And foundations, I think, have a different roles to play. Different foundations sort of work differently. And CNCF is obviously quite central to a lot of things going on in the cloud native space. And again, I think people love the idea that it's making lots of decisions versus what's actually happening is lots of people in lots of projects are making lots of decisions. And the CNCF provides a sort of place where a lot of those technology people can just talk without the barrier being we work for competing companies. So I think that's the main aspect of that. The other part is it's also driven wholesale awareness of, I guess, what we would probably put under that banner of cloud native applications and cloud native infrastructure. And ultimately that shift, the ability to do that across lots of sort of companies, and including really small companies like the one I work for, is ultimately something that everyone can say. Like when you're talking to large corporate organizations who aren't going to hear your individual voice as loudly, they can associate you with something that they want to do. And that association is really powerful. So I think as all shouting with one voice, that ultimately that motion, that sort of DevOps transformation, that move towards automation, that move towards developers being a larger part of like the operations story, automation, API driven infrastructure, like SaaS as a, like all of those things we can all broadly speaking agree on, we can put under one banner and shout about it. And then when we get into the details of how do you want to do that very specific thing, well, yeah, we can offer competing solutions. I think that to me is the sort of utility of something like the CNCF. People look down on marketing, and actually turns out marketing is really powerful when done well. It also is that place where technology people who work for, often quite fiercely competing companies can talk about things in the context of like, no, we work together. We just happen to work for different companies. And I think that's also really powerful. That doesn't need a foundation. Like, let's be clear, that does just need the project. But the foundations do a load of things that most of the people in the project probably wouldn't do otherwise.
What do you think is the role of standards in this, in terms of interop, well-defined interfaces? I'm guessing that all leads nicely to your point of people working together around a common abstraction.
Yeah, I think like especially capital S standards, I think get a bad rep. People tend to run away. I don't think that's going to change. I'm not sure I agree. I would like to see more work done around standardization. I think more commonly, though, what we're seeing is the sort of people trying to build things that become de facto standards. And where that works, it works really, really well. That plethora of open source projects around like the cloud native space, so many of them sit atop containers. Like they're either helping people manage containers, they're helping people secure containers, they're helping people build containers. They're using containers as an abstraction such that they can say, yeah, that bit is really easy because then we don't have to deal with the huge complexities of the previous generation. We can standardize on this one and build higher level useful things. That fundamentally happened down to a widely sort of adopted implementation in Docker, but also the really smart move of standardizing a bunch of the low level bits. So the work that the OCI did, and well, OCI was formed for that purpose of standardizing the runtime, the image format, the distribution specification. And you look now at, and there's good points and bad points about that, but the number of companies with container registries basically expands every few months. The reason that that's not as much of a problem as it could be for most end users is because they're all fundamentally based on the distribution spec. Turns out that's not 100%. They're just completely interoperable. There's always things people will do on purpose and not on purpose. But for the most part, these things are transferable between different registries, can be runnable on different runtimes. And you see things now like Google Cloud Run as an example of like you could just take a container and run it over there. Hyper was doing that before and was sort of maybe ahead of its time. All of this was fundamentally based on these standards. You don't want too many standards and you don't want to standardize things and then hit people over the head so they use them. But I do think that like the work on specification standards that we can all agree on, common undifferentiated things are an interesting space. The serverless working group around Kubernetes has really took that route with the cloud event spec and is now doing some similar things there. They've been looking for opportunities to ultimately find areas where they can agree. Everyone doesn't have to agree, but they've been finding interesting areas where they do agree and really like basically writing those down, documenting them and doing lightweight standardization processes. The CNAB work recently I was involved in at the start, but I mean, obviously been taken on by former colleagues now. I'm at Microsoft Docker, I'm Pivotal, we're involved there, other projects as well, really around sort of, I guess, a higher level packaging. A lot of that doesn't end up having to be end user facing either. There's certainly a near infinite number of more people who would use Docker without knowing about OCI, but then they get the benefits of that built in. Similarly with CNAB, I think lots of people will look at things like that and go like, how do I use it versus how do things that I might use it? Most people don't need or want to care how the thing does it. If people have solved shared problems, then that's below the line. They care about them solving your end user problem, which is the way it should be. But yeah, I think you certainly see conversations around that sort of where can we build agreement, I think is a good question for a lot of the working groups around the space.
Yeah, I like that. And that leads nicely on to another area I wanted to explore with yourself is sort of this CNAB space, things like build packs. I see a lot of interesting things going on with the build pack, things a working group in Kubernetes and now and so forth. What is your thoughts on the good and the bad of things like build packs?
Another area that I think sort of has surprised a bunch of people, but is interesting, is ultimately container build. I mean, ultimately, it's software packaging. One of the innovations really with Docker, and I think one of the sort of things that maybe was there to happen and Docker really hit on the right time, right place, and sort of it happened around it, was the shift of software packaging from being a activity that was done in the sort of corner of the IT department. You had a few people who did software packaging, and everyone else was like, we don't want to go to know these people, but we need to do sometimes to get our software packaged, but then we will run away. And it like, again, I fell into like doing a bunch of software packaging things before, so I could put myself in that space. So ultimately, what happened with Docker was software packaging shifted really rapidly to be something that individual developer teams did all the time. And there are trade-offs with how that happened, with ultimately Docker build as the sort of user interface, and ultimately the OCI image spec describing the result of that. But one of the things you can't argue about is just how widely adopted that was, how simple that was to make that transition. And if you talk to people who are experts in Debian packaging, they will list off all the things that are wrong with Dockerfile, and rightly so. On the other hand, there are 600,000 or plus public Docker files. Actually, no, there's a lot more than that. There's probably several million. I'm thinking of compose files. There's definitely several million Docker files public on GitHub. There's a lot more not on GitHub, or not publicly so. It really helped to democratize software packaging. But there are trade-offs there. And I think what there's been interesting for a while is, can we also have other types of build tools? And you start to see those emerging around the OCI spec. Can we have other ways of building things? So Jib is an interesting tool from Google, and again, like specifically for Java ecosystem. And again, like if you can say, look, here are remove a load of the general purpose nature of the problem, and what does build look like? Build packs are similar. Build packs basically provide a sort of high level abstraction, really, to saying, look, you don't need to deal with a lot of this. As long as you fit into this gap, I will deal with all that complexity for you. And there are some nice properties there. I think build packs ultimately has been of interest to people who are already using a similar technology in the context of Cloud Foundry. As a direct end user tool, I think it has some downsides. I think where I'd see much more interest in something like build packs is it being built into, I guess, things people are already using. Like, to me, build packs isn't the end user interface, it's an implementation detail. I really liked the recent Spring integration. So I don't know if it's in the latest version of Spring or if there's a plugin, but I think there was talk of this going into sort of the default Spring project, where ultimately it will automatically generate the build process to simply build your Spring project into a container using build packs. That, I think, is where you don't need the sort of generating lots of different things to do that. You just need something that has encapsulated all of those problems. And build packs, to me, is sort of a project that's doing that, I think, interestingly. But again, there's other build work going on as well. I mean, the evolution of Docker build was basically into a library called BuildKit. Lots of software now is using BuildKit as the library to do build without needing the rest of Docker. And that's then plugged back into Docker as well as the next generation of the build process. There's still some work to do there around supporting Windows containers last time I looked, but there's already a bunch of sort of improvements to the syntax and language and the ability to extend the Dockerfile syntax. But I think for me, Dockerfile ends up being this surprisingly blunt but incredibly low barrier to entry, sort of great 80% solution to the problem. I think what we'll see isn't necessarily tools that take that same approach. I think we'll see basically more singular tools around specific ecosystems that use things like build packs or others that ultimately just result in like an OCI image being created without you really, it's an implementation detail more than a step where I'm writing something and building a container image.
Yeah, totally makes sense. So what do you think a best practice continuous delivery pipeline would look like in a Kubernetes world?
I think the reality is that it's basically about your organizational context. There is a lot of technology evolving really quickly in this space. There are multiple projects in the CNCF as well as the CDF. There is everything from project end users who've successfully deployed something and are running things in production to projects that have like large backing from large technology vendors. This space is incredibly hot. I think what that does mean is that there's a richness to all the tooling, although then everything is moving really quickly. It's probably also why I would wager the most popular tool in this space for doing this is Jenkins, because everyone has it, everyone knows it, everyone, broadly speaking, can get it to do anything they want. So I think that's a really difficult question to answer. Like in a greenfield environment with a lot of expert Kubernetes people, your answer is going to be very different to, like in your context, there are SaaS options. It's just, I hesitate to sort of give a concrete recommendation because everything dates really quickly. I'm interested in Tekton personally. Not necessarily as everyone should go use Tekton directly now. So Tekton is a project under the banner of the Continuous Delivery Foundation. There's contributions from folks at Red Hat, Google, Puppet, actually, a bunch of other folks. I've written some tasks for it for Snyk and for some of my open source projects. What it's really doing is providing the primitives for software build on Kubernetes. So Kubernetes is extensible. So it adds things like pipelines and tasks to Kubernetes as constructs in the same way as you would have deployments or pods or services. For me, that's solving an interesting problem because at that point, you could actually have interoperable tools on top using the same, like you're starting to decouple the tool you use to drive those things with the details. And I think that might be how we get to genuinely better tooling. It may not. There are certainly other things going on around the work that Argo and the Argo Flux integration is doing there is sort of taking a slightly different approach. I'd love to see more things built on top of Tekton because I think the interoperable bit appeals to my sort of nature. And then the Kubernetes native objects is a useful API abstraction.
Yeah, a lot of folks are loving the CRDs.
I'm not sure about loving. I think it's a powerful abstraction. There are certainly advantages if you understand it. It's a high barrier to entry. So I think whether it's CRDs, like whether it's operators, I think that we need to be very conscious that viewing these as like end user things is probably a mistake. Viewing the tools that might use those things as end user things, that's the power that we have of an extensible platform. I think that if people feel that Kubernetes is complex, and actually, people talk about that, but actually the wide scale adoption and people actually actively using it day in, day out that aren't Kubernetes experts and don't care about KubeCon and the rest of the stuff we will get into, they're not using these things and they don't find Kubernetes overly complicated versus what they were doing before. The moment you start throwing in CRDs and operators and the rest of it, the complexity goes through the roof. I do feel that they're an implementation detail of the things we can build. Not that they're bad. They're not the end result for like the end user.
I'd love to switch up gears now with our time remaining and talk about some security stuff. I know you're big in the security world. I do see it becoming more popular at KubeCon and just in the ecosystem in general. What do you think are the biggest security challenges with Kubernetes? And where I want to frame this is, are they more technology focused or are they more people focused?
I guess to answer the last question first, like security problems are always socio-technical. They're always people and technology. It's nearly impossible to say one is more important than the other because it will depend on the actual problem at the time. And Kubernetes security around that space is no different. I think, though, what I'm touching on something we talked about previously around the shift of software packaging from being the sort of thing in the corner of IT to something that developers owned and own today and own the problems associated with it. I think what we're seeing is security being another area where we're seeing it shift from a small group of people who take all of the responsibility and bear all the load for that and try and act a sort of gate to good or bad. Ultimately, that breaking down, and security is another thing that's just shifting towards being a developer problem. That isn't to say, in the same way as like with software packaging, it's not to say there aren't some experts who really know how to do the high-end bits. Security definitely needs security experts. It's not, you had that conversation around the sort of DevOps movement of like, oh no, we're going to get rid of all the systems operators. That's not what happened. Whether you want to put them under an SRE banner or another, ultimately you've seen a resurgence in classic operations conversations because people have seen their value. Security is going to go through the same like existential crisis of like, oh no, all the security work is going to shift to development teams. And what do the security people do? And the answer is be security experts. Stop playing whack-a-mole with thousands of things when you should be dealing with the high risk, high complexity security problems. So I think it's in that context around what's happening with Kubernetes, because Kubernetes is getting used in a lot of places where that shift of lots of responsibility, operations, packaging, configuration, security is happening, pushing down to developers. So what are the security tools and the security problems that are fundamentally application security problems? But they spill into this sort of what would have historically been IT and infrastructure space. That line, that diagram we would have historically drawn of IT owns shared databases and the servers and the load balancers, and application teams own the Java application, and security works with those two bits. That's breaking down. And the developers are bringing their own databases and running them on top of Kubernetes. They're owning more of the data. That sort of traditional, it's just the DBAs who have access, that's disappearing. It's in that context that I think all of this is happening. And developers need help to understand that new responsibility. But also security people need often new tooling and help to understand that this really rapidly moving world of new technologies, but also the fundamentals like API-driven, ephemeral, dynamic infrastructure. It's no longer good enough to say, oh, can you give me a list of all the IP addresses? Well, when you say a list, can you give me a spreadsheet? It's like, I think it will be out of date by the time it's generated. Is that useful? And suddenly it's like, okay, we need to talk about security fundamentals. So yes, there's a lot of like having specific security problems. But I think one of the main things for people suddenly having this realization is go back to basics and do a shared threat modeling exercise, like with developers and security people in the room, And suddenly you start spiraling into all of the security fundamentals without making the assumptions about technology. I think then you'll discover the problems, and you'll discover them yourself, and sometimes you need to go through that process. It's good to see some of the working group activities here. I mean, like talked briefly about CNCF. There's the special interest group specifically around security in CNCF. So not just Kubernetes, the whole sort of space. The security days, KubeCon was really good. And yes, there were software vendors there, but it's very much been marked out as a place that isn't about like individual vendor tools or anything else. It was a good sort of cross section of end users. A lot of the talks were driven by people's real problems. And the sort of work that's going on around that sort of community, I think, is really interesting. Again, like cross section of end users, developers, contributors to the project, and some really deep security people. So lots to learn.
Yeah, good stuff. So say, for example, I am new to the space and, I'm good. Threat modeling is great and sort of bearing in mind the social technical things. Is there a few sort of quick wins? Say I'm completely new to the Kubernetes and sort of, security space. And I'm just doing some POCs to convince my fellow teammates. Is there some security sort of 101 stuff I should get in the mix?
Yeah, I think there's a few things that it's worth considering pretty early. One is really just a bit of understanding Kubernetes and understanding the defaults aren't that secure. I think that's something that the Kubernetes project and folks have been discussing for a while. And this isn't mistakes as much as hindsight of massive success, I think is how I'd put it. But if you understand the defaults, and some of the examples might be that things may be running by default as privileged. So basically they have like more access than maybe they need to do. Often things will run with writable file systems. And if you can avoid that, you can cut down on all sorts of like threat vectors. The default in most clusters that a pod can use as much resources as it can get its hands on the node, and then basically other things will get thrown off. And again, like you end up with lots of risks around resource starvation, which might be because you wrote bad code or you're running someone else's bad code, or because someone's trying to launch a denial of service attack. And so adding limits can at least mitigate some of those problems. But I think understanding that the defaults are not secure and then looking at, okay, I need to address those insecure defaults on a per application basis and understand like how things are configured, I think is one area. Another area is obviously like the applications you're deploying, are they secure? Because honestly, the biggest problem aside from people putting that unsecured Kubernetes control planes on the internet, don't do that, is the short version to that question there. The other part is the applications. And like people might not compromise your cluster, but if your application has like SQL injection problems or cross-site scripting problems, it doesn't matter that they haven't compromised you. You could have the most secure Kubernetes cluster in the world. If it's running applications that are fundamentally easy to compromise, you're still hosed. Turning around and going like, but they didn't get the cluster when they stole all your data and your application's been down for weeks or whatever. It's like, no one's going to think, well done you. You don't unfortunately win by protecting your bit, like you're protecting the data or the compute or whatever it might be, not the thing you put into the mix that provided that service. So ultimately thinking about the applications, are the applications you're building secure? And like, do you have a load of vulnerabilities in them? And like from the code you're writing or from the third party like code you're bringing in? I think those two are probably the best places for me to start, simply because it doesn't require you to buy into all the other tooling. I think there's other areas where, I mean, if you're a larger company, you already have a SOC. There are like intrusion detection type systems and monitoring systems that have become useful. If you have monitoring tools or BI tools, getting data from your cluster into those, but you still need a level of, I guess, expertise there to interpret the signals and use that data. There are certainly things on the developer side that probably you can scale out faster that will cut down the signal there as well as help. Again, different contexts are going to need different protections. If you're in regulated environments, like PCI environments, whatever it might be, you're going to have to go the whole gamut. But bang for buck, secure your applications and understand the Kubernetes API surface isn't secure by default, I think are a good starts.
Super advice, Gareth. Thank you very much. I saw Ian Coldwater at KubeCon this year, and their keynote was very much think like an attacker. And that was really helpful for me. And basically what you're saying here is think about your actual cluster and think about your apps as well.
Yeah, and that's a really good talk to watch. And so Ian also did a talk with Duffy from VMware on the defaults problem with Kubernetes from a security point of view. That's really worth watching.
Super. I'll add the show notes and everything else we discussed today as well. I'll put the show notes, the links in there. You and I could probably chat for days here, but we've limited time. So as a wrap up, if people want to follow your work more closely, they want to reach out to you perhaps on the interwebs or something, what's the best way to do that for them?
I'm Gareth R on most of the internet, I think, at this point. I'm Twitter and GitHub and SpeakerDeck and all sorts of bits of content there. And yeah, obviously the Snyk, snyk.io, you can sort of head over and see some of the things we're building in this space as well.
Super. And I've got to do a shameless plug for your newsletter as well. I'm a long fan of your newsletter.
I wear too many hats is the problem. So yeah, in my vanishingly small spare time, I curate a newsletter called DevOps Weekly, which I've been sending out for 10 years, which is a frightening amount of time to be sending a weekly email out. But yeah, it's basically a roundup of things, broadly speaking, in the DevOps space, automation, people things, technology things, normally sort of a dozen or so links every week.
I'm a long-term reader. I find it fantastic. I think I was there pretty much from day zero. And it's one of those things, a couple of newsletters I definitely like. They give good pointers to what's interesting in the space, where things are evolving, obviously through the lens that you're sort of currently looking at. But no, I'd really appreciate all your efforts. I know it's not easy to put these newsletters together. So trust me, there's many of us out there reading it and we are super grateful.
Thank you.
Cool. Well, thanks for your time, Gareth.
Yeah, always good to chat.